In the journey of electrons, we got a fantastic Nobel Prize winning chemistry, that is the lithium ion battery chemistry by Dr. John Goodenough, Dr. Stanley Whittingham, and Dr. Akira Yoshino. It is a fantastic chemistry in that lithium ions are moving forward and backward between two electrodes, and it is powering all our portable devices, handheld devices, and recently it is also testing for our electric vehicles. But in terms of more safer and more sustainable and more low cost batteries, we need more new battery chemistries, and we need to explore the alkali metal uh, batteries and alkaline earth metal batteries. Then how we can compare this alkali metal and alkaline earth metal batteries. Um, from my recent readings, I am getting the information that comparatively alkaline earth metals are more safer and better than alkali metal batteries. How? Because it is safer because it is less reactive than the first group elements, and it can provide one more electron than the first group elements. So it can provide 2 electrons per atom by increasing the energy density with the same volume we are going to take. And that is one of its advantage. And if you are calculating the earth abundance and sustainability of the components using in that, etc., we are getting more new chemistry. We need to explore new chemistries from alkaline earth metals, just like calcium, magnesium, etc. And when we are thinking about the solid state batteries, the basic thing with electrolysis is that when we need the electronic movement from one side to other side, at the same time the ions are moving from one side to other. We need that motion also through the electrolyte. So molten salt is a fantastic example for electrolysis because we got the maximum speed of ions, and thereby according to the rate of movement of electrons through the outer circuit, we are getting the maximum movement of ions because it is molten salt. And in solution also we are getting the motion or the movement of ions from one electrode to other electrode. Then our doubt is that how we are getting such type of a movement or such type of a transferring in solid state batteries if you are taking all the components including the electrolyte in a solid state. How we are going to get these solid state batteries that we are eagerly waiting for. And the third thing is that ion batteries versus the metal batteries. In ions, the movement of ions are there from two two strong electrodes, positive and negative electrodes. But in metallic batteries, pure metal constitute one of the electrode, and when the electrons are going through the outer circuit, the one of the electrode is gradually undergo degradation. That is our favorite reaction, that it needs to undergo degradation, and during discharging and during charging it need to plate on the same electrode. How we can achieve that 100% plating of this one without any degradation. And so I think with the ion electrolyte, that's also the liquid electrolyte, if we are taking two strong electrodes for positive and negative, we we are getting a fantastic chemistry, but we need to explore in terms of safety and in terms of less reaction with the atmosphere and water, etc. And we need to take into consideration the low cost, and we need to take into consideration about the earth abundance, everything we want to explore. So it's a time for exploration, and we are eagerly waiting for that, how these scientists are going to make or going to overcome these problems in this journey of electrons.